In this video, we are going to discuss routing protocols in computer networks. The network layer in the TCP/IP protocol model has three responsibilities: packetizing, addressing, and routing. A routing protocol is responsible for finding the best path for a packet and delivering it to the destination. When a packet is transmitted by a host, it has to make several hops on its way to get to the destination. For example, a message sent from host 1 in the United States meant for host 2 in Japan has to pass through many routers. Finding the best route for a packet is done by intermediate routers. To be able to make routing decisions, routers need to have the IP addresses of the other nodes in their routing table. They also need a routing protocol to determine what path to take. For example, in this picture, we see the routing table of router 2, which contains information of the other nodes, the cost to transfer to them, and the output link of the packets for each destination. Communication of nodes over a large network is done through circuit or packet switching. In circuit switching, a physical circuit is established before data communications, and all of the messages will be sent over the circuit or path. So for each data transfer, three steps must be taken by the sender and receiver. First, connection establishment, second, data exchange, and third, connection release. For example, in telephone systems, the caller dials a number to create a physical connection with the destination. Then he or she talks to the callee and then hangs up to release the connection. In this type of switching, the connection is physical, which is called circuit switching. In computer networks, packet switching is used between source and destinations. In packet switching, a data message is going to be sliced into packets, and then packets will be sent over the network. It has two types: virtual circuit and datagram. The virtual circuit is very similar to the circuit switching, but the circuit here is virtual. The source and destination nodes, as well as the intermediate nodes, agree to reserve some resources, such as bandwidth, to create a path and forward data packet over the created path. However, in datagram, there is no connection establishment or release. Data packets will be sent through various paths depending on the routing decision. In this picture, we see an example of a virtual circuit. First, a connection is going to be established between host 1 and host 2, shown by the red color. Then host 1 forwards its packets over this path in order, and all of the packets will be delivered to host 2 in order as well. This method is mostly used for networks such as ATM and MPLS, where the quality of service is an important factor. In virtual circuits, as well as circuit switching, the routing decision is made only once when the connection is created. However, in datagram, a data message is going to be partitioned into small packets, and each packet is going to be sent over the network individually. These packets may arrive at the destination out of order, so they first need to be reassembled and then delivered to the user. In this method, each packet is going to be routed separately, and routers must make routing decisions frequently. Since no connection is needed in this method, it is less expensive than the virtual circuit, like the internet. Routing algorithms can be classified into two categories: static and dynamic. In static routing protocols, the routing decision is made without regard to the current topology of a network. For example, in broadcasting, an incoming packet will be sent over all outgoing links. As a result, the static protocols work best when the topology of the network is fixed. However, over the large network, such as the internet, nodes constantly join and leave the network, and the routing protocol has to be able to keep up with the change. Otherwise, data packets may get lost or go through an overloaded path, which end up with packet loss or delay. Therefore, dynamic protocols such as distance vector and link state adjust to the topology change by exchanging routing data with other nodes. In distance vector routing, each router has a table that stores the best distance to every other node with the output link. Adjacent nodes exchange their tables to update their routing information. RIP, or Routing Information Protocol, is a distance vector algorithm that was used in ARPANET. In a distance vector algorithm, each node stores information of every other node in its table, which makes routing tables large and their updating a lengthy process. However, in link state routing, each router stores the distance to its immediate neighbors. Then it will create a packet called link state packet containing all information it has learned from its neighbors and broadcast it all across the network. This way, all routers will be able to update their routing tables. It has been proved that the link state works faster and more efficiently by having only the information of the neighbors. As a result, routing protocols of the Internet, such as OSPF, are of link state types.